Welcome back to the Deep Dive. Today today's going to be a little different.
Yeah, a bit of a pivot.
Right. Usually we are looking at a specific tech trend or maybe analyzing a business strategy. But today we are looking at the actual board game rules for the entire universe.
That is a very humble way to put it.
Right. We have this massive stack of notes and research that claims to be the architect's map to reality. And I will be honest, when I first saw the topic, I got that little tightness in my chest.
The high school physics trauma.
Yes, exactly. That trauma where I just assume I'm going to have to do complex math on a whiteboard in front of the class.
Which is exactly what we are not going to do today. The sources we are pulling from make a really crucial distinction for you right out of the gate. Physics is not just the math.
Right, the math is just the tool.
Exactly. The math is just the tool we use to describe it. Physics is actually the source code. It is the attempt to answer those massive questions that keep you awake at 3 in the morning.
Like, why does time only go forward?
Right. Or why are we solid if atoms are mostly empty space? What is actually happening when you flip a light switch?
And the way these notes are structured is just fascinating. It is built in layers.
Which is really helpful for breaking it down.
Yeah. So we're going to start with the stuff you actually feel every day. Heat, time, energy. Then we zoom out to the massive stuff like gravity and light speed.
Really big picture.
Right. And finally, we zoom all the way in to the quantum level, where the rules, frankly, just go completely off the rails.
They really do. It is like peeling an onion. And the more layers you peel back, the more you realize that your daily intuition about how the world works is, well, it is mostly wrong.
Because our brains evolved to hunt and gather right.
Hmm.
Not to understand quantum mechanics.
Precisely. So let us start with layer 1, the engine of reality, energy.
It is a word we use 100 times a day without really thinking about it. I don't have the energy to go to the gym, or that room has bad energy.
Sure, colloquial energy.
But the physics definition in the source material is deceptively simple. Energy is just the ability to cause change.
That is it. If nothing changes, if nothing moves or heats up or glows, there is no energy being used. It is the literal currency of the universe.
The universal budget.
Yeah, and the first rule of this currency, the first law of thermodynamics, is that the bank is closed. You cannot print more money.
Conservation of energy. You can't create it, you can't destroy it, you can only shuffle it around from one form to another.
Which sounds super abstract until you apply it to yourself. The notes had this great breakdown of the human body. We tend to think of ourselves as these biological machines, but physically we are just temporary storage vessels for ancient starlight.
Man, this was the first huge mind-blown moment for me reading through this. We can actually trace the burger I had for lunch.
Let's do it.
So the burger is beef, the cow ate grass, and the grass converted sunlight into chemical energy via photosynthesis.
And where did that sunlight come from? Fusion?
Hydrogen atoms smashing together.
Yes. Right in the core of the sun. So when you walk down the street, that kinetic energy, the literal movement of your legs, is released solar fusion energy.
That took an 8-minute trip to Earth and just got locked inside a plant.
We are entirely solar powered.
It makes you feel very connected to the cosmos, honestly. But the notes pivot to something a little darker.
The inevitable decline.
Yeah. If energy is never destroyed, if it is always just changing form, why do things die? Why do cars break down? Why does my coffee get cold?
Right. If the energy is still there, why does the universe feel like it is running down?
Exactly.
The tragedy of the universe.
Drama queen.
I mean, it is dramatic, though. This is the second law of thermodynamics. While energy is conserved, its quality degrades over time. It spreads out. We call this entropy.
Entropy is disorder.
Mm-hmm.
But I think people really misunderstand the word disorder here. They think it just means like a messy bedroom.
Yeah, it's not quite that.
The sources use this deck of cards analogy that really clicked for me. It is actually about probability.
Right. Technically, yes. Entropy is probability. Think of it this way. Take a fresh deck of cards. It is perfectly ordered. Ace to king, all the suits organized.
Okay.
That is low entropy. Now throw the deck in the air. What are the odds it lands back in perfectly organized order?
0. Absolutely 0.
Practically 0, yes. Because there is only one way to be perfectly ordered and trillions upon trillions of ways to be messy.
That makes total sense.
The universe is exactly the same. There are way more ways for energy to be spread out than concentrated in one place. So statistically, heat always flows from hot to cold.
So the heat from my coffee spreads out into the cold room.
Right, and the room heat will never spontaneously gather back into the cup.
And this is what gives us time, isn't it? Because the sources make this really bold claim, the arrow of time is just the increase of entropy.
Precisely. We only perceive the future as the direction where things get messier.
Wow.
If you watched a video of a shattered glass leaping off the floor and assembling back onto a table, you would know instantly the video was played in reverse.
Because it violates the second law.
Exactly. Time is essentially the universe trying to balance its books, spreading energy out until absolutely everything is just a uniform, lukewarm soup.
That is incredibly bleak, but it explains so much. Weather, for example.
Yeah.
I never really connected thermodynamics to thunderstorms before reading this.
Well, weather is just a giant heat engine. The sun heats the equator way more than the poles.
Which creates an imbalance.
Right, that imbalance is low entropy, it is order, and the atmosphere hates that. It wants everything to be the exact same temperature.
So hurricanes and jet streams.
That is just the atmosphere frantically trying to rush heat from the hot bits to the cold bits to even it out.
So a catastrophic hurricane is just the universe trying to get comfortable.
Exactly. And even your own biology relies on this. Osmosis in your cells. That
Yep.
is just particles moving from high concentration to low concentration.
Seeking balance.
Yeah. You are only alive because your body is fighting a constant, desperate battle to keep your energy organized against that constant pull of entropy.
We are basically little islands of order in a universe that just wants chaos. Okay, so that is layer one. Thermodynamics gives us the flow of time. Now, let us shift to layer two. We are zooming out to the really big stuff.
The heavy hitters, mass, speed, and gravity.
And we really have to start with the famous equation. E equals mc squared. Everybody knows it. It's printed on coffee mugs. But I feel like very few people actually know what it implies.
Most people think it is a formula for how to build a bomb.
Right.
And I mean, it is, but the philosophical implication is way cooler than that. It says energy equals mass times the speed of light squared.
And the equal sign is the key part there. It means mass and energy are the exact same thing.
They are completely interchangeable. Mass is just super condensed energy. You can think of it as frozen light.
Frozen light, I love that.
The reason atomic bombs or the sun are so insanely powerful is because of that c squared part. The speed of light is a huge number.
300,000 kilometers per second.
Right, so you square a huge number, you get a gargantuan number. Meaning a tiny, tiny pinch of mass contains a civilization-ending amount of energy if you could actually unlock it.
The source material had this one line that stood out to me. Every sunrise is matter dissolving into radiation. The sun is actually getting lighter every single day because it is turning its own physical body into sunlight.
Millions of tons per second, just gone, converted directly to light.
But this naturally leads to the cosmic speed limit, that 300,000 kilometers per second mark. This is the one rule everyone seems to want to break in sci-fi. Why can't we? If I just build a big enough rocket, why can't I go faster than light?
Because of that equation again, mass and energy are intimately linked. When you push an object, you are adding kinetic energy to it.
Making it go faster.
Right, but as you get closer to the speed of light, that energy has to go somewhere. It actually starts acting like mass.
Wait, so you get heavier?
Effectively, yes. Your inertia increases. To get to 100% of light speed, you would become infinitely heavy.
Which would require infinite energy to push.
Exactly. And since there isn't infinite energy in the universe, you can never quite get there.
Nature's hard cap. But weird things happen when you try to get close. This is special relativity. Time gets really squishy.
Squishy is a highly technical physics term.
Well, you know what I mean.
No, it is perfectly accurate. We are used to time being this constant ticking clock that is the same for absolutely everyone. Einstein proved that is completely wrong. Time is relative to how you are moving through space.
There was this concept in the notes called the speed budget that really helped me visualize this.
Oh yeah, that is a great framework. Think of it like this. You are always moving through space-time at a constant speed. The speed of light.
Always.
Always. Right now, sitting in those chairs, we aren't moving through space very much at all. So almost all of our speed budget is being used to move through time.
We are aging at maximum speed.
Thanks for bringing that up.
Yeah.
But yes. Now, if you get in a rocket and move through space at 99% the speed of light, you have diverted most of your speed budget into spatial movement.
So you have very little budget left for time movement.
Exactly. So your clock slows down drastically. You could fly to a distant star and back. For you and the ship, it might be 1 year. But on Earth, everyone you know has been dead for centuries.
You effectively traveled into the future.
You did.
And we really have to clarify for you listening at home, this isn't just a whiteboard theory. We use this. GPS relies on this.
Fair. Every single day. GPS satellites are moving at thousands of miles an hour in orbit. Because of that, their clocks tick slightly slower than the clocks on our phones.
By just microseconds, right?
Right, just fractions of a second. But if engineers didn't program the satellites to artificially compensate for Einstein's relativity, Google Maps would drift by about 10 kilometers a day.
You would miss your highway exit within 24 hours.
It would be totally useless.
That is just the wildest validation of a theory. My digital map works, therefore time is a flexible construct.
It is brilliant.
Okay, so speed bends time. But then there is gravity. Layer 2 also completely redefines gravity. Because I grew up thinking gravity was a force, like a giant magnet inside the earth pulling my feet down.
That is Newton's view, and it works fine for apples falling on heads, but it fails completely for things like black holes. Einstein came along and said, no, there is no invisible string pulling you. Gravity is just geometry.
The sources use the classic trampoline analogy here.
It is the best way to picture it. Imagine a heavy bowling ball sitting in the exact middle of a trampoline. It curves the fabric down into a ball shape.
Right.
Now roll a small marble across the edge of the trampoline. The marble naturally curves toward the bowling ball.
But not because the ball pulled it.
Exactly. It curves because the physical fabric it is rolling on is warped.
So in reality, the earth is the bowling ball.
Yeah.
And space itself is the fabric.
Right. Earth bends the space around it. When you jump in the air, you aren't being pulled back down by a force. You are simply sliding along the natural curve of space-time that the Earth's mass created.
You are just falling into the dip.
Falling into the geometric dip. Yes.
It is genuinely beautiful when you think about it. Planets aren't being held on a leash by the sun. They are just rolling along a curved highway the sun built for them out of space.
A curved highway with zero friction, which is what an orbit is.
Okay, so let's review. Thermodynamics tells us time flows because energy spreads out. Relativity tells us space and time are flexible fabrics bent by mass. Everything makes logical sense. Cause and effect. Big things follow predictable rules.
And now we go to layer 3.
The quantum realm.
And this is where we have to apologize to you because logic is about to completely leave the building.
The sources have this great transition here. They basically say, everything you just learned, throw it out. When you zoom in to the incredibly small subatomic level like electrons and photons, the rules change completely.
It is exactly like a video game where the physics engine just glitches out if you look at the pixels too closely. And the absolute hallmark of this glitch is the double-slit experiment.
Okay, walk us through this one. I have heard of it, but I always get tripped up on the actual implications.
It is a simple setup. You have a solid wall with 2 vertical slits cut into it. Behind that wall is a blank detector screen. You start firing stuff at the wall. Let's say we fire tennis balls.
Right.
Some tennis balls bounce off the wall, some go through the left slit, some go through the right slit. You get 2 piles of tennis balls hitting the back screen.
2 straight lines of impacts. Makes perfect sense.
Now do the exact same thing with light. If light is a particle, like a little tennis ball, you would expect 2 bright lines on the back screen, left slit and right slit.
But you don't get that.
No, you get an interference pattern, a whole series of stripes across the back screen, bright, dark, bright, dark, bright.
Which means it's acting like a wave. Like if you push ripples in a pond through 2 gates, the ripples crash into each other, cancel out in some spots, build up in others, and make a complex pattern.
Right. So the early physicists saw this and said, okay, mystery solved, light is a wave. But then they got very clever.
They usually do.
They decided to fire the photons one single particle at a time. Click, wait, click, wait.
Because surely a single tiny photon particle cannot ripple through 2 doors at once. It has to choose one slit or the other.
That was the assumption. And yet after firing thousands of single isolated photons one by one over time, that exact same complex wave pattern built up on the back screen.
So the single photon interfered with itself.
It mathematically implies the single photon went through the left slit, the right slit, neither slit, and both slits all at the exact same time. It traversed every possible path simultaneously. This is what we call superposition.
Sounds like a ghost.
It is basically a probability cloud, doesn't have a strict location. But here's the part that actually upsets people. Physicists said, this is crazy. We cannot have particles being in 2 places at once. Let's put a tiny sensor right by the slits to actually watch which door the photon uses.
We're going to spy on the photon to catch it in the act.
Exactly. And the very moment they turned the sensor on, the interference pattern on the back screen vanished. The light went right back to acting like boring old tennis balls. Just 2 straight lines.
Wait, just by measuring it, the behavior of the universe changed.
Yes. This is the famous observer effect.
Now, does this mean the photon knows we are looking at it? Is it conscious? Because that is exactly where my brain goes when I hear this.
That is the very popular sci-fi interpretation, and it gets repeated a lot online. But the actual physics is much more grounded, though still incredibly weird. It is not about human eyes or consciousness. It is about interaction.
Interaction.
Right? To measure something, you have to interact with it. You have to bounce a laser off it or touch it with a magnetic field. That physical interaction destroys the delicate probability cloud. It forces the universe to decide, and the photon basically says, fine, I am right here.
So before we actually measure it, reality is just a maybe, is a fuzzy cloud of could be.
Yeah.
And only when we measure it does it snap into an is.
Exactly. And Einstein absolutely hated this. He famously said God does not play dice with the universe. He wanted everything to be predictable and physical. But quantum mechanics says no. At the fundamental level, reality is just probability math until it hits something.
That is deeply unsettling. It implies the universe is only rendering graphics when we look at them.
It is a very simulation theory kind of thought. But it actually gets us to our final layer, layer 4. Because how do we actually know any of this subatomic stuff? We literally smash reality open to look inside.
The Large Hadron Collider, the LHC.
The biggest, most complex machine humans have ever built. A 27-kilometer underground ring buried on the border of France and Switzerland.
And the description in the notes of what they actually do down there is so metal. They are accelerating protons at 99.99999% the speed of light and crashing them head on.
It is a literal demolition derby for subatomic particles. But the goal isn't just to break them into smaller pieces. Remember our old friend E equals mc squared.
Energy can become mass.
Right. The collision energy inside the LHC is so unfathomably high that the sheer kinetic energy condenses into brand new heavy particles that have not existed naturally since the Big Bang.
They are forging pure matter out of pure speed.
And the absolute crown jewel of this whole endeavor was finding the Higgs boson, sometimes called the God particle.
Which I know physicists absolutely hate calling it.
They despise that name. But the discovery proves something profound. We used to think empty space was just empty, a true void. The Higgs discovery proved that the entire universe is actually filled with this invisible energy field called the Higgs field.
The notes compared it to a cosmic molasses.
It is a perfect analogy. Imagine trying to walk through a pool of deep water. You feel resistance drag. That drag makes you feel heavier. The Higgs field does exactly that to fundamental particles.
Oh, I see.
As electrons move through this completely invisible field, they interact with it. And that very interaction is what gives them mass.
So if the Higgs field were to just somehow turn off.
You, me, the Earth, the stars, we would instantly disintegrate. Our electrons would lose all their mass and zip away at the speed of light. Atoms wouldn't be able to hold together. We only exist as solid physical objects because we are constantly swimming through this invisible ocean.
Wow. So to recap our architect's map of reality here, we have thermodynamics. Time flows forward purely because energy spreads out.
Check.
We have relativity. Gravity isn't a pull, it is just curved space. Space and time are flexible.
Check.
We have quantum mechanics. Everything tiny is just a probability cloud until it is observed. And finally, the Higgs field. Mass only exists because of an invisible cosmic ocean.
That is the map. But there is a glaring hole in it.
Of course there is. We can't have all the answers.
It is the grand unified theory problem. Relativity, which governs the really big heavy stuff, and quantum mechanics, which governs the tiny fuzzy stuff, mathematically hate each other.
They don't talk.
They absolutely scream at each other. If you try to use quantum math to explain a black hole, which is a massive amount of gravity from relativity crammed into a tiny space from quantum mechanics, the equations just break.
What happened?
You get infinity as an answer, which in physics basically just means you are completely wrong.
So we're missing a massive puzzle piece. Quantum gravity.
That is the holy grail of modern physics. The person who figures out exactly how gravity works on subatomic particles wins the Nobel Prize of all Nobel Prizes.
It is very humbling. We can smash atoms and predict the exact age of the sun, but the fundamental glue of reality is still just a massive mystery.
It keeps the job interesting. Physics is not a finished textbook by any means. It is an active detective story that we are barely halfway through.
I really want to leave you listening with the final thought experiment from the sources, because this one really stuck with me. It is called the speed of light lag.
Oh, this is a good one.
If the sun were to vanish right now, just poof, completely gone from the universe
We wouldn't know.
for 8 minutes and 20 seconds.
Right, because gravity travels at the exact speed of light, And light obviously travels at the speed of light. So for over 8 minutes, Earth would continue to orbit a completely empty patch of space.
We would look up and see the sun shining. We would feel the warmth of it on our skin. We would essentially be living happily in a path that no longer physically exists.
And then all at once, complete darkness, and we instantly fly off into the void in a straight line.
It really drives home that we're all just trapped in our own little local bubble of now. We never actually see the universe as it currently is. We only ever see it as it was. When you look up at the stars tonight, you are quite literally looking at ghosts.
Well, on that intensely existential note, I hope your commute feels a little more cosmic today.
And just remember, if your living room is incredibly messy, it is not your fault. It is just the second law of thermodynamics.
I am absolutely using that excuse.
Me too. Thanks for taking this deep dive with us. We will see you in the next one.